I will be very honest, I think in 5 to 10 years we will all be eating bugs that will be 3D printed to look like steaks. I think we're all going to be eating 3D printed food in a couple years. We're already like getting involved in 3D printed chocolate, and then there's also the 3D printed meat, so why not more foods than that?
Yeah, my name is Chad Bridgewater. I'm a assistant professor of digital fabrication design here at SUNY New Paltz. A lot of the CAD experience I have is drawing in the computer, making things go from a 2D to a 3D, and also the fabrication that goes along with that. So running 3D printers, CNC routers, laser cutters, vinyl cutters, things like that. And I use it for my own practice just as much as I do for classes. So the first time I got introduced to CAD was a class by a professor named Frankie Flood. He used to teach at UWM and now teaches down in Appalachia State. And we had a class where we did 3D modeling and we built 3D printers. So it was a lot to digest, but it was a lot of useful information because we were actually making the 3D printers with the CAD drawings, and we could customize them, custom colors. We would powder coat things. And so I first learned how to fabricate digitally as I learned how to 3D model.
Sure, my name is Aaron Nelson. I'm Associate Professor of Digital Design and Fabrication in the Department of Design. I'm also a lead researcher in the Hudson Valley Additive Manufacturing Center. I was introduced to CAD as a graduate student. I took a workshop at the Haystack School up in Maine with an artist by the name of Joe Wood, who taught at the Massachusetts College of Design. And he did a workshop on Rhino where we just drew stuff in Rhino and then we laser cut some stickers. And that was the first time I was ever introduced to CAD. When I graduated from graduate school, I went to work for the University of Arkansas, the Department of Architecture there, where they use CAD to build buildings. And that's really where I kind of got my start. And from there, I worked there for 4 years. I eventually became Director of Technology for the program, and then came to SUNY to be Assistant Professor.
My name is Ike. I am a current DDF grad student, and I am the TA of CAD 1 and CAD 2. My bachelor's degree is a BFA in ceramics, and our professor here, his name is Brian Sebez. He builds and designs clay 3D printers. So for his addition to the course was adding CAD 1, and so that I took as my first class in New Paltz because I thought it'd be fun and it seemed like it'd be an interesting course for me.
Hi, I'm John Duffy. I am an electrical engineering major with a minor in digital science fabrication. I was introduced to CAD actually freshman year of high school, where I was part of the kind of guinea pig program for what became the Intro to Engineering class, and I got exposed to a lot of really cool stuff with 3D printing and CAD software. I personally really like digital design fabrication because it's kind of a mix between art and engineering. Engineering, you're used to using a lot of very heavy mathematical formulas and whatnot to construct something, and in art it's more free form, and you're able to use your creative imagination as well as what you want. And I like to view digital design fabrication as a mixture of both.
Well, I can't quite speak for engineering and computer science necessarily, except for that I feel like the digital fabrication is more hands-on. We're actually creating and fabricating things, not just creating them maybe like in the computer. So there's more hand fabrication as well as digital fabrication in the DDF area as well as in CAD. So we might start in the computer and draw the things in the computer, but then we have to output them through certain types of machines.
Well, computer science is all focused on coding. That was one of my two majors going into college. And engineering has a lot of different elements. So I would say that DDF, digital design and fabrication, is more similar to engineering, especially mechanical engineering, than it is, for example, computer science. But what those two lack is the design component. A lot of this is about refining designs and trying to combine humanity with designs.
CAD design is something that is touching every field where you make things. And so this goes across from the entertainment to the engineering fields, architecture, building and design, construction. And we put a lot of emphasis on teaching our students to be really proficient in CAD. And so if you have a skill in CAD, you can kind of walk into a lot of different industries. They're always looking for people who are competent. Rhinoceros 3D is a 3D modeling program, and there are a lot of different flavors of 3D modeling programs or CAD programs, but that's the one that we primarily use the most. It is an enterprise level software, which means like big companies use it, but it is also relatively cheap and extremely extensible, which is one of the reasons why we use it so much. Is you can write your own plugins for it. There's a ton of add-ons and things that can enhance the things you can do in Rhino.
I personally love looking at articles about how they use concrete pours as 3D printers to make houses in combination with rebar. And I think it's a really cool and interesting design to simplify and speed up the process of like building houses or just building things in general.
Oh, I think that medical is really important. My brother's a biomedical engineer, and he's designing things for constant EEG, but also if you look at the face transplant surgery, that is all done with 3D printed elements. And then even if you look at the HVMCs, I remember correctly, they reprinted someone's aorta. I hope that someday will be reprinting bones and stuff and just reprinting arms. I think that'd be awesome. I think that's not for another couple hundred years, but I think that'd be amazing.
Yeah, I think that's where you'll find a lot of jobs too. You're starting to see things in construction. You mentioned the medical field, jewelry and metalsmithing. They use that quite a bit. We used to hand carve a lot of those rings. A lot of it's 3D printed in wax and then cast in traditional fabrication processes. So I think you see a lot more crossover. You see even like 3D printing in Hasbro. They make action figures, and you can get yourself made as a G.I. Joe or a Star Wars figure. They 3D print the heads, and then they mass produce the bodies. So you see it being brought in commercially. But I think with what you're talking about, the desktop revolution is kind of what we're seeing. We're seeing a lot of desktop 3D printing, desktop machining, and I think that's where you'll see that increase. And that's where we've seen that increase in the past 10 years.
I think the main thing that we do differently than a lot of those programs is that they are teaching students to enter a particular field. If you are studying computer science, the idea is that you're going to go become a programmer somewhere. If you're studying in a program like industrial design, the idea is you're going to go become an industrial designer. If you're studying in one of the engineering programs, you're going to go follow one of those engineering pathways, be it mechanical engineering, electrical engineering, or computer engineering. I think what we really do differently is we don't necessarily have a specific pathway that our students are supposed to pursue. A lot of the opportunities that our students generate are opportunities that they generate for themselves. We sort of fill in a lot of the technical things that students need to know, and they come with their ideas. So we've got students who are really interested in automotive design and they want to go work in the automotive industry. We have students who are interested in character design and they want to go into either animation or one of the CAD related illustration style programs. We've got students who are really interested in construction, and so they want to go into some of the building trades. We've got students who are interested in furniture design and they want to go into that. So there's a lot of different pathways you can take from our digital design and fabrication program, and I think that's the thing that really sets us apart is we allow students to sort of come in with a set of skills. We add a bunch of technical skills to it, and then they can take that on sort of their own path. Most of our students, though, because of where we are located, tend to migrate towards the entertainment industry, so theater and television. There's a lot of sort of prop making that happens in the area, and they are always looking for people who are competent in CAD design, people who are competent in fabrication, and those are the students that we produce. Fabrication is always sort of at the forefront of that because that's the way we make things, and so it's really awesome to see all the sort of multiplicity that's been happening in the fabrication space with the introduction of computer numeric control, and now with the introduction of AI, we're seeing a lot of how AI can automate a lot of the sort of difficult processes of fabrication.
I'd say they're more recyclable than reusable. A lot of the materials in 3D printing, such as PLA, polylactate acid, are recyclable with industrial composting. So the 3D prints can be recycled. A lot of the machining that's done with the CNC routers out of aluminum or steel, that stuff is recyclable. But I say more recyclable than reusable, really.
Some of those plastics we can recycle. The PLA plastic that we print with in the lab we can compost. But the thermoplastics are really just stand-ins for other materials, and as our understanding of materiality becomes more complex, we'll be able to replace those materials, those thermoplastic materials, with materials that are a little more robust, and thus hopefully allow us to recycle and create a sustainable way to fabricate objects.
It's hard to say with AI coming in, and if we're talking more in the classroom or in production, because 3D printing's been around since the 80s. CNC machining has been around. The first CNC machine, I think, was in the 50s that they built. And so the stuff has been around. It's been in industry quite a bit.
I think we learned a lot about how long supply chains have gotten in terms of getting goods from manufacturers to consumers. And I think that experience that happened during COVID has opened a lot of people's eyes into how important manufacturing is. As the tools become more available to people, as they become more available to smaller businesses, you're going to see a real sort of democratization of fabrication happening, where we won't have goods that are made in one particular place in the world and then have to be shipped or transported around to individuals, but instead we'll live in sort of an economy of digital files, and you'll have digital files that you'll buy and be sent, and then you can produce those on site either at a centralized location that is close to you or perhaps in your own home with some sort of advanced fabrication device.